Today we're going to talk about illustrating position using an R vector. It's a more common way of doing it actually in the long run, and we'll talk about why that is as we get farther into the class. So we're going to have R1 as our original position vector here. We'll say it's 15.0 meters at an angle of 55.0 degrees east of north. And we'll go with position vector 2, which is going to be equal to 25.0 meters at an angle of 45.0 degrees north of east. So this would look like this. If we set up our axes, you can see R1 is going to be 15 meters at an angle of 55 degrees east of north. Well, we go from north 55 degrees, so it will be 35 degrees north of east, or 55 degrees east of north. So vector 1, vector 1 is going to be here. Vector 2 is a little bit longer and is at approximately a 45-degree angle. So this is vector 2. And what we're going to try to figure out is the distance between the two. So these are two position vectors. Essentially, it would look like this. If we were to set the 0, 0 point in the back corner of the room, we would have one vector that would say that my position is 15 meters at an angle of 55 degrees east of north from that position. Maybe right around here. Okay? We would have one that was 45 degrees north of east from that point, a distance of 25 meters, which would actually be farther, probably be somewhere in the hallway. Right? So we'd have two spots, one about where Landon is, and one somewhere out in the hallway. And we're trying to figure out the distance between these two. We're trying to figure out this piece right here. The way we illustrate that is we could say, well, position 1 plus, plus this, which we'll call delta R. Delta R is equal to position 2. In other words, the difference between the two of them is position 2 minus position 1. So our goal is to figure out the distance between the two of them, which in the end ends up being the second minus the first. Okay, so how are we going to go through and do this? What's the first thing we need to do? Isha?
Break the vectors down to components.
Great, so pick one and break it into its components. Isha?
So if you take R1, you have to do the, so you have to draw the triangle to show the different components.
We've actually pretty much got the triangle drawn on the board, right? We've got R2, which is right here. We've got R1, which is right here. We can figure out, in terms of unit vectors, position vector 1 and position vector 2.
So you have to use the angle.
Go ahead.
So the R1 in the y direction is equal to the R1 times the sine of 55.
Okay, R1 times the sine of 55 degrees, you said, is in the y direction, right? So I'm going to put a J right there. Yeah?
35, because you're going.
Right, got to be careful, because the angle I described as 55 degrees is this angle right here. This angle right here is 55 degrees. It is more common to use this angle, which is your 35 degrees. So yes, it would make sense to make this 35 degrees. Okay, keep going.
And then your other side would be that R1 would be in the x direction would be R1 times the cosine of 35 times I.
So you see, this is our position vector 1 in the x direction. This is position vector 1 in the y direction, and we multiply them by I and j to give this as a unit vector. So position vector 1 in terms of unit vectors, please. I'll take it when you got it.
12.3.
If I can hear it, though.
12.3.
12.3.
I plus 8.
Okay, I need more than 3 sig figs, however, because we have 3 sig figs in our given, so we should go to maybe 6 here.
Okay.
2872I plus
8.60365.
J, okay? That is position vector 1. We can also go through and figure out position vector 2. What is position vector 2 going to be equal to?
It's going to be the R1 cosine of 45 degrees, I, plus the R1 sine of 45 degrees plus J.
Not plus,
Or, sorry, J, yeah.
multiplied by J. Isha?
Should it be R2?
Just be careful, we've got 1s and 2s
Okay.
here, just gotta be careful, that's okay. So Evan, what are the numbers here? What's 2? Position 2?
2 is 25 meters.
25, okay, I got the rest here. Cosine 45, I plus 25 sine of 45J. Position vector 2 then. I'm sorry, I missed it, go ahead.
17.67757.
I plus,
They're both going to be the same.
oh right, 17.6777J. And that is also in meters. Our goal here is to figure out the distance between the two. So, we have to figure out delta R. Position 2 minus position 1. So, we need to write out both of these. 2, which is 17.6777I plus 17.6777J minus the quantity of 12.2872I plus 8.60365J.
5.3905.
Okay, so what's the first one?
5.3905. Haven't done the second one yet.
Here, let's do it this way. Let's actually walk our way through it. We have to combine 17.6777 minus 12.2872 times I plus 17.6777 minus 8.60365J.
So the first one is 5.3904.
I
And the next one is 9.5740. Okay.
J. Okay. So far, we have the vector delta R. My question is, what's the distance between these two positions? So what do we need to do with this? Sakura?
We need to like put it back into one straight line.
Okay.
Like, reverse the component. Okay. So we need the Pythagorean theorem.
So we're going to figure out the magnitude of delta R. So we need to use the Pythagorean theorem to do so. Sakura, go ahead.
Okay, the square root of 5.3904 squared plus 9.0740.
Therefore, the magnitude of the displacement vector between these two vectors, position vector 1 and position vector 2, is With sig figs, 10.6 meters. So these two positions are 10.6 meters apart.